Hello and welcome to Agile Data Science. Today we're going to be going over the basics of both Agile as well as managing data science projects and how those two things can align in order to ensure that your projects and teams are run successfully. So for today, we're going to be going over a couple of main topics. Starting out with, we're going to start with data science projects. Who drives them and what are they? Followed by problems in managing data science projects or a data science project. Going over the data science process itself, then going into Agile and kind of discussing what is Agile, going into a few things that can be known as Agile, such as Scrum and Kanban, as well as then kind of interloping both of these concepts, Agile as well as data science project, and figuring out how Scrum and Kanban and things like that can actually be used to help improve your data science project process. The purpose of this video is to kind of give you a good overlay of a lot of concepts, maybe some of you know, maybe some of you don't know, and really kind of bring this mesh together, because it's really about bringing two complex processes together where you're trying to join things like Agile with things like data science. Okay, let's start out with the what, in the sense that what drives the need for data science projects. And specifically, one of the big drivers is business goals. So at the end of the day, data scientists are really trying to do a few things, and one of those, or two of those two things are, increasing profits or decreasing costs. And those are kind of as basic as it gets. Along with that, there is other things that data scientists might do, which is trying to figure out ways that you can better perform and create products that can then compete with your competition. This might not necessarily directly lead to increased profits. It might purely be, in some ways, a loss, but only ensuring that you can keep competing with your competition. And with that, it becomes very important that data science projects and processes become very aligned with the business, in the sense that there needs to be kind of an understanding of what the goals are overall, and also where the data scientists are in helping the business get to those goals. And so this is kind of where you start running into some problems. So the problem with kind of running a data science project is that it doesn't necessarily always align both with the business and software needs. And there's a lot of reasons for this. There's a lot of reasons for why you don't always necessarily align. Sometimes this can be due to limited resources, which just, ends up having a lack of priority. One of the big problems with data science today is finding the right talent. And if you don't have enough of the talent, like, how do you make sure that they are doing the right thing with the business? Because oftentimes the business is doing so many different things, it's hard to necessarily align with every goal if you are a data science team. So you're limited on the work you can do just because of your basic resources. There's only so many people, thus there's only so much you can do in a day. And this is kind of one of the major roadblocks that you'll often face as a data science manager or team lead, because you only have so many people, and you'll have everyone across the organization, whether it be finance or analytics or something similar, they'll all want a piece of a data scientist's time. And so how do you make sure to manage that time correctly when you have so many requests coming in? Another that's very important is research and analysis isn't always finite, in the sense that there isn't always a complete stop. Especially with complex data sets, it can sometimes be really an infinite amount of time that you could spend analyzing data and getting different insights from that data. But again, this kind of comes back to you having to align with the business needs, and why it's really important that data scientists align with business needs, because they need to make sure that projects kind of have a clear end and kind of have clear goals. And this is something that data scientists don't always do, and honestly is not necessarily 100% natural at all time. There's really a lot of different things that can impact your ability to communicate clearly to the business what your problems are. Oftentimes, because business and data science kind of speak different languages, it's not always easy and clear to speak where you're at and what still needs to get done. And that's kind of one of the bigger things. What we'll talk kind of about later is that, the data science process on its own doesn't really say what still needs to get done. And this kind of makes it hard for the business to know where they can move strategically. And so this kind of lack of communication, these other problems, kind of impact how the data science team and the business teams interact. And oftentimes this leads to misalignment and issues happening because things don't go at a pace that everyone is expecting, and nothing is as clear as it should be. Now, one way that a lot of data scientists have kind of tried to approach this, to kind of try to improve this whole process, to improve the communication, to make it kind of clear what steps need to occur, is someone created the OSEMN model, which is, or framework really. It's really just a framework of high-level concepts that happen in the data science process. And all that stands for is obtain, scrub, explore, model, and interpret. Now, what this actually means, you can actually add data to the end of all this. So obtain data, scrub data, explore data, etc. So each of these steps are a different key step in the process to analyzing data. Now, for those of you who are very familiar with the waterfall method, it almost kind of comes across very similarly, where it really is kind of step by step by step. So first you've got to obtain the data. And for those of you who've worked in data science projects, oftentimes this can be a very tricky part because, sometimes the data is external, sometimes it's internal, sometimes it's both, sometimes it's coming from multiple data suppliers, and you're having to develop, ETL pipelines and systems and processes just to kind of get this data from wherever it lies, whatever application system it lies in, and pull it out. And this will often be done by someone like a data engineer or software engineer that will pull that data out. And also in many companies where there aren't maybe a full stack of data engineers, maybe you're having the data scientists do it themselves. So they'll often obtain this data, pull it out. Now the next very time-consuming step, often people will say it takes 80% of data scientists' time, is the scrubbing and cleaning of the data. Now this is the next step where you're often spending a lot of time, deduplicating data, cleaning up data, making sure it's all clean, making sure there's no test data, making sure all the dates are formatted correctly, making sure all the data you get in is formatted correctly, again, removing bad data. It's really a very strenuous step because there's a lot that goes into it. There's a lot of different little pieces that go into it, and making sure your data is standardized can take a long time. In addition, if you're then developing a data warehouse or something like that, off of this data, it might also take even more time because then you're having to develop some sort of fixture that will be there for a longer time than just for this analysis. Now, generally, if you're just doing your first time analysis, you might not necessarily build a data warehouse. This might just be a temporary thing. And so you might just be doing that analysis right away for now. But it is kind of these two key steps that take, honestly, a good portion of the time, just obtaining and scrubbing that data. Now, next, after that is kind of that explore step. This is what will often be referenced as EDA, exploratory data analysis. So you're just kind of exploring the data. You're really looking at charts and graphs and running different, maybe testing out different models on it and just exploring to see like, how is this data all related? How does this data kind of look? And so that's that EDA step. It's a very key step in just kind of understanding the data, getting a general kind of feeling for that data. Kind of take this model step. How people approach this is different. Some people will, write out a clear hypothesis and then try to answer that based off of, developing some sort of model and supporting it with, different charts and graphs to support that, or something similar to that. And so this model step can be run many ways. In fact, a lot of third parties are trying to develop systems that can just basically do this model step automatically, because it's arguably something where you can just run some models based off what you think. You can do some feature engineering, et cetera, to kind of run this whole system. And then finally, interpret. Now, this is where you kind of start sharing those results. And this is where you start trying to take this and take it to the business and actually lay out what you found out, so that the business can start taking that and working with it. Now, sometimes they'll take it and implement it into a software system. Sometimes you're just doing something where you're giving strategy some clear insights into what they should be doing. Maybe you're working on fraud detection and you now have a whole new view on how fraud detection should go. So this is kind of the basic framework that a lot of data scientists have kind of followed. It really does take on different forms. Like before I even knew what OSEMN model was or framework was, I'd done something similar. I'd usually more do it without the obtain step. But most data scientists will kind of follow this ideology because it kind of makes sense. But the problem is it still doesn't really provide a framework and a clear understanding of how the project should be broken down. So let's kind of go on with that. So what does the data science process not really do? And what it really doesn't do, and like I just kind of mentioned earlier, is it doesn't really develop a general timeline and plan that can be kind of communicated to management. It gives you that overall framework, but it doesn't really kind of break things down into what would be usually understood as manageable steps that kind of clearly show where roadblocks can happen and all these different things where, if you're a PM, you understand these concepts. And you can then explain it to the business and kind of clearly communicate between the two, what's going on, what still needs to happen, right? Like just because that, you're that obtain step, it doesn't mean you kind of know what the steps are afterwards to get to the end, right? Like, and that's kind of the thing. Like you run into a lot of these issues, like for instance, in the EDA step, it's not a finite thing. That's one of the things we point out earlier. Analysis could be borderline infinite, where you could keep answering questions. And so if you don't have clear goals and steps into place, it could technically go on forever. And so these data science projects in some cases have no end. It's often very open-ended. And I've been in that case where, I was really given an open-ended question. and very little understanding of what the goal was. There really needs to be a clear step of, well, what's the strategic goal here? As a data scientist, what are we trying to achieve here? Because without that, you can spend all day analyzing this data. You can spend all day trying to figure out some sort of insights, but if there's no clear goal, you're not going to know where you're going. And so this is kind of the problem of the data science process. There's no clear end. So this is where Agile can help. So for those of you who don't know what Agile is, this is where kind of Agile can come in to help. So Agile is really a set of frameworks that kind of act as project management tools. They aren't in themselves project management, but they are frameworks that can help you manage a project. So we're going to kind of go over a few key terms for Agile processes and frameworks, and we're going to kind of go over the Agile Manifesto. I think that's an important step to understanding why the Agile methodologies have kind of come about. And we're going to go over Scrum and Kanban. And just to kind of start off early, Kanban's not necessarily an Agile methodology. It's just there's a lot that was taken from Kanban that has been put into Agile methodology. So I think it's really important to kind of point that out. And you'll often use things like Kanban boards, which we'll talk about shortly, and things like that. And we'll kind of go over the history and why it really isn't an Agile methodology as is, but has kind of been used and adapted into Agile processes. So let's talk about some key terms and concepts behind Agile. So what you'll notice kind of in this corner is this circular loop of people kind of, clearly they're kind of collaborating on a project. And that's kind of one of the key things that we'll talk about later on with the manifesto is Agile. It is that kind of ability to have collaboration and continuous feedback. But let's start with the concept of stories. Stories are generally written down as in the statement and in the framework of as a blank, I want to be able to do something. And that's how you kind of write out as a user, how you want to be able to interact with a website typically, or an application. So this comes again from software. And so these stories are kind of broken down tasks into their smallest kind of feature. That way they're kind of clear when they end. So as you're kind of going forward through the process, you're going to end up taking these stories, and typically they're put on some sort of board. And they kind of move through that board, and they'll move through, things like QA step and to do and, finished, and they'll have this board, and we'll kind of go over it later when we talk about Kanban. That kind of lets you see where things are, and that lets you know what's still left. It helps you communicate later on to management where you are, where you need to go. And so again, it kind of creates that clear communication, clear ability to talk and show where things are going. And so that's why, they're really important. And again, they're paired typically with some sort of board. Sometimes it's a Kanban board. Again, a lot of times what you'll see is a lot of companies won't necessarily do a specific Scrum or Kanban, but they'll often take different pieces of frameworks and meld them together. So some companies might is called a stand-up, which is a meeting in a day. Some won't, but they'll use a Kanban board to do their work. It really depends. So continuous user feedback is another very key step, because a key thing about being Agile is constantly making sure your customer, whoever it is giving feedback to you about your product. This allows you to kind of make sure you're going the right way, you're doing the correct process. The product is going to be the thing that they want at the end. And that's a big problem that has happened with older methods, is oftentimes you'll finish a project and it's not what the customer wanted. So now, do you still demand payment? Do you not? And so this was supposed to kind of get them more involved. And thus by being more involved, they are happier typically, hopefully, at the end. And then minimal marketable features. Again, this is kind of a concept where you don't want to wait with your code to finish till the very, very end. You've got 100 features in there, and you finally figure out that half these features aren't even used. You kind of want to kind of pull out features as they come. But now let's kind of keep going, and let's go with the Agile Manifesto next. So in order to kind of understand Agile, I think the Agile Manifesto is arguably the best way to kind of understand what it's really trying to do. It really just breaks it down into 4 very concise ideas. So for instance, individuals and interactions over processes and tools. The whole point there is to say, it is better to focus on the individuals and interactions over the processes and tools that you're using. It's better to talk about, what team you have and work with them over getting too caught up in the processes and tools. Next, working software over comprehensive documentation. So oftentimes, especially in waterfall method or something like that, you'd spend months, maybe even a year, gathering requirements to figure out something for an end customer. And you'd spend months gathering this and building documentation and designs and doing all that. And you'd never actually put any effort into building software. And then you could either, not have a product at the end because maybe they don't want it, or something like that. So they've really started to focus more on working software, and that's next is customer collaboration over contract negotiation. Again, this is more about, don't spend too much time on all the details, but really make sure the customer kind of has a clear understanding of if you add this feature, how much it's going to cost. But like also at the same time, make sure you're just kind of building it as you go, give a general outline for where it's going, and then kind of work with them from there to make sure that they understand what's going on. This builds, better kind of trust between both parties, but at the same time, hopefully creates a better product that meets everyone's needs. And then finally, responding to change over following a plan. One of the big issues, especially that used to happen with software again, is you'd spend a year gathering requirements, another year building the software, and now your software is obsolete. So responding to change is a very important step because it allows you to kind of keep flexible. It allows you to change when things happen, when you need to use new technology, when you need to take in a new API or new data. You're not stuck using the schema or something that was talked about a year ago, but you can quickly adapt and not feel enclosed into some previous idea. So let's start with Kanban. Now, again, if you heard me earlier, I told you Kanban in a weird way is not exactly an agile methodology on its own. It was actually developed earlier in the 1940s by Toyota, and it was really developed as a way to kind of improve their productivity against American manufacturers at the time. And specifically, again, this is manufacturing. This is not software development. This was more assembly lines and developing of cars. So this really has less to do with software and more to do with manufacturing. So really, this is kind of what the Kanban board looks like, right? Like this is a very high level, very basic one. You'd have more kind of swim lanes in here, not just to do, doing, and done. You'd have things like to do, in development, in QA, in implementation, done, or something like that, where it's a little more complex, especially with software. So that's why I kind of say Agile in itself, or Kanban in itself, is not necessarily Agile. It is a concept that is used in Agile, but not necessarily in itself an 100% Agile methodology. All right, so now let's talk about Scrum. Scrum is actually an Agile methodology because it was actually developed in that light, in the light of we wanted to develop a product or a process, a framework, and we want to make sure that you understand that Scrum is a framework that helped provide guidelines for how to run projects more iteratively. That was kind of one of the key steps. One of the big things about Agile is kind of creating those iterations where you're kind of repeatedly going over every 4 weeks in a sprint, and you're repeating what's been done, what still needs to get improved, what's been done, what still needs to be improved, what's been done, what still needs to be improved. And you're going over those iterations, and each iteration you're improving the product, you're adding more features, you're making sure that something is delivered at the end of every sprint. We're going to talk about a couple of the terms that you've probably maybe heard. So again, we talked about user stories already. As a user, I want to do something, right? And that's kind of the basics of it. The backlog. So the backlog is kind of an important concept in the sense that this is where all the user stories kind of go, and then you spend time prioritizing what's next. And that's something you'll usually do every 3 weeks, 4 weeks, where you're going to kind of sit around in a meeting and say, okay, what have we done? What do we still need to do? You kind of do this review process, and you kind of figure out if you're on the right path, if you need to reprioritize things. Again, this is where you start bringing in customers or stakeholders to kind of review, like, hey, this is where we're at. What do you still need done? And so that's kind of an important step. Stand-ups, again, kind of popular both in Kanban and Scrum, and they really just act as a meeting where you talk about what you did yesterday, what you still need to do, what are your roadblocks, and where having that open communication and dialogue has actually saved time in the company. And then finally, sprints, which are just that 2 to 4 week process that happens where you do development and you kind of have some goals in order to develop that kind of minimal viable kind of product at the end or features that you want to deliver. And that's kind of what this loop here is with this time. It's usually kind of shown that way as a sprint, where it's just this 2 to 4 week thing where you go over and you iterate, you go over, you iterate, you go over and you iterate, and you keep kind of developing your product further and further through each sprint. So Agile and data science. The first thing is obviously, can it work and how does it fit into this whole process? So let's kind of talk about the benefits and the challenges. So some of the benefits that you get from having an agile process, especially in data science, is you improve communication. You really have an opportunity to kind of clarify what you're doing in those stand-ups, whatever it might be. You have an opportunity to talk about the different bits of analysis you've done, maybe some insights you've already come up with, that can already be turned around to the business. in a stand-up or in a review. You can kind of spend that time reviewing and showing, hey, we've already figured this stuff out in the last 2 to 4 weeks. And so that kind of gives you that constant communication. So the business kind of can already start adapting to changes that you found out and information you found out, even if you haven't finished the product itself or project. Again, that kind of helps prioritize limited resources because, again, if you only have 2 data scientists, they can only do so much work. So as they're kind of putting through and doing their different analysis and developing different metrics and different algorithms, you can kind of start seeing what's fitting into the business strategy and what's not. Maybe they figured out that this data set they were hoping to find insights in didn't have anything, and so now you've got to throw away a whole project. Or maybe you had insights and they weren't what you wanted, so you can't put in the feature or something like that in your product because it doesn't make sense. And so like those limited resources get better prioritization because it's a much clearer what they're doing, what they've done, and what those results are. And this is kind of where like iterations fit naturally with the research because they're going to kind of constantly be giving out research. If you read in the O'Reilly book, they talk about, iterate for data science and charts, graphs, whatever, because it really is every 2 to 4 weeks you should be doing, new analysis, showing new kind of little bits that you've learned and kind of building it up into that final product. But again, having each step, each point be an opportunity to share what you've done. And now, just because that's true doesn't mean, or all these benefits are true, and it's really helpful to have, some agile methodology concepts mixed in. There are a lot of challenges. For instance, data science work doesn't always lead to a deliverable, and when you have a framework, specifically Scrum, where it kind of almost demands an end product at the end, and you don't always have that with analysis, you might keep just analyzing data. You might not have this crazy amounts of, a final report or a final algorithm at the end of 4 weeks. And I think here the answer typically is, you just want to kind of keep iterating with charts and graphs. And I think that's the best solution, is to kind of keep giving little bits of what you have learned. If you haven't learned anything, it's not the end of the world. If you're constantly showing what you do know, any insights you have gathered, and maybe the things that you haven't, maybe, the things that where you've had dead ends, it kind of gives everyone a better understanding of what's going on. And then also, sometimes analysis just leads to trying to get that last 5% of precision and accuracy, which might be the hardest to do because maybe it's because you need more data, more features, things that take time. All this being said, the key kind of point here is that Agile, it's more than just for software. It really can be taken, and like we talked about with those benefits, it can be applied to data science projects. You can use it to help improve communication. You can use it to help, reprioritize projects. It really has a lot of versatility and can be applied in very different ways. Now, how you apply it is very different. You don't necessarily look for as strict end results at the end of every sprint. You try to clearly state goals, but you also have an understanding that analysis sometimes takes a little longer or might not be as finite and might just lead to more questions. But then you just make sure that those are kind of your end deliverables, or some basic insights that you've already found out. Those few little things can actually help, again, the business see where you're going. They help them understand maybe if they think you're going the right way or the wrong way. And that improved communication, that improved prioritization really helps you align with the business. That's really how I look at agile data science. It's not about, putting this strict guidelines around programming and data science. It's about creating this framework where you have this improved visibility, you have this improved communication where people kind of know where things are going and how they can go from there. So, hopefully you enjoyed this kind of intro video. If you're kind of interested, that's all I have for you today.